problem. A horizontal cross section is 14 meter long and is simply supported at its end. Full stop. It carries two concentrated load as shown in figure. Calculate the deflection of the beam under the load C and D and take E as a 200 Gpa and I it is 160 into 10 raised to power 6 mm raised to 4. E means it is modulus of elasticity. So first of all, to calculate the reaction of beam, first step to calculate reaction of beam, calculate reactions of beam, okay, reaction of beam, okay. So just first of all, when movement it is clockwise, it will be take positive. When movement it is anti-clockwise, it will be take negative, okay. So for clockwise, it will be take positive value. For anti-clockwise, it will be take negative value, okay. So first of all, take movement at summation of ma is equal to 0. Apply the first equilibrium equation, that is summation of ma is equal to 0. Here we need to apply summation of ma is equal to 0. Movement at a is equal to 0. If it is movement it is clockwise, it will be take positive. If movement it is anti-clockwise, it will be take negative. So first of all, we start from A to B, okay. So first 12 kilonewton, how it is rotating? 12 kilonewton, it is rotating clockwise direction, okay. Force into perpendicular distance. So 12 into distance, it is 3 meter. Then second one, it is 8 kilonewton. 8 kilonewton, it is also rotating clockwise direction, okay. It is rotating clockwise direction, okay. So 8 into total distance, it is 6.5 plus 3, it will be 9.5. Then last one, it is RB, reaction at B. It will be rotating anti-clockwise direction, okay. So it will be RB into total, it is 14 is equal to 0, okay. So here it is reaction RA and at B it will be reaction RB, okay. So RB it is rotating anti-clockwise direction. It will be get from this relation reaction at B, okay. So calculate reaction at B. So 12 into 3 then plus 8 into 9.5 divided by 40. So it will be 8 kilonewton. So RB it will be 8 kilonewton, okay. Then apply second equilibrium equation, summation of Fy is equal to 0. Summation of Fy is equal to 0. Algebraic sum of all the vertical force is equal to 0, okay. Here we need to assumption when force it is going upward direction, it will be take positive. When force it is going upward direction, it will be take positive. If it is going downward direction, it will be take negative value. If it is going downward direction, it will be take negative value, okay, negative value. So RA it is going upward, RA, then minus 12, then minus 8, then plus RB. RB we are calculated, it is 8 kilonewton. So put here 8 is equal to 0, okay. So from this relation it will get reaction at A. RA is equal to 12 plus 8 minus 8. So it will be 12 kilonewton. 12 kilonewton. Okay. So RA is equal to this 12 kilonewton. RA is equal to 12 kilonewton. Okay. So all these value it is in kilonewton and meter. Okay. So next, Young's modulus it is given. Young's modulus and RA it is 8 kilonewton. I will write down RA is equal to 8 kilonewton. 8. Okay. So Young's modulus E is equal to, it is given 200 GPa. 200 GPa. To convert it is in Newton per mm square. So 200 into 10 raised to the power 3. It will be Newton per mm square. Newton per mm square. Okay. So this is Young's modulus. It is in Newton per mm square. Okay. So next moment of inertia it is given. I is equal to, it will be 160 into 10 raised to the power 6 mm raised to 4. Mm raised to 4. Mm raised to 4. Okay. So we need to calculate EI value. EI is equal to total. EI is equal to, it will be 200 into 10 raised to the power 3 into 160 into 10 raised to the power 6. 160 into 10 raised to the power 6. Okay, so it will get EI value from this relation. EI 200 into 10 raised to the power 3 into 160 into 10 raised to the power 6. So it will be 3.2 into 10 raised to 12. 3.2 into 10 raised to the power 13. 13. So unit it is Newton mm square. The unit it is Newton mm square. So we need to convert all this value in kilonewton meter square. So convert this Newton mm square to kilonewton meter square. So EI is equal to so first of all write down 3.2 into 10 raised to the power 13. So first of all convert it is in Newton to kilonewton, means we need to divide it by 10 raised to the power 3. 10 raised to the power 3. Then meter square, we need to convert it is in mm square to meter square, means 1000 square divided by 1000 square. Okay, so it will get kilonewton meter. Okay, now it will be get kilonewton meter. Okay, 3.2 into 10 raised to the power 13 divided by 10 raised to the power 3 into 1000 square. Okay, so it will get 32 into 10 raised to the power 3. 32 into 10 raised to the power 3. This value now it is kilonewton meter square. Kilonewton meter square. Okay. Okay. So EI I will write down here. EI is equal to 32 into 10 raised to the power 3 kilonewton meter square. Meter square. Okay. Meter square. Okay. So reaction at A it will be 12. Reaction at B it will be 18. Now apply the Macaulay method. Macaulay equation. Okay. So Macaulay equation. So RB it is, I will write down here, RB is equal to it is 8 kilonewton. 8 kilonewton. So now apply the Macaulay equation. As per the Macaulay equation, we know that I will start here. EI into d2y by dx square. So first of all, take moment. Just consider section XX. Just consider section XX. First of all, consider section XX. We take section XX in that way. In that way, the point load will be covered. Okay, all the point load it will be covered from any side. Okay, so I will take from the A side. Okay, support A. So take section XX at a distance X. Okay, so write down. Consider section XX at a distance X from support A. Okay, from support A. So now take moment at XX. Moment at XX. Okay. So here clockwise it will be take positive, anti-clockwise it will be take negative. Moment at XX it will be 12 into X, 12 into X, then minus. Now 12 it will be rotating about the XX, it will be anti-clockwise direction. So again 12 in bracket. The total distance, how much this distance? Here, this distance it will be, this distance it will be x minus 3. Okay, this distance. So this distance it is x. Okay, so this 3. So x minus 3 it will be get this distance. Okay, so that's why it will be x minus 3 bracket close. Then minus 8 in bracket in bracket. So next x minus. So now we need to calculate this distance. Okay, so this distance it will be x minus 9. 9.5. So 3 plus 6.5, it will be 9.5. X minus 9.5. Okay, so it will be x minus 9.5. X minus 9.5 bracket close. Okay, so this one it is movement at x-axis. Okay, so now apply Macaulay's equation. So ei it will be d2y 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 divided by dx square divided by dx square is equal to m is equal to m. Okay, so moment at x-axis we know that ei d2y by dx square d2y d2y divided by dx square divided by dx square is equal to moment at x-axis how much? So it will be is equal to 12 into x minus 12 into in bracket x minus 3 then minus 8 in bracket x minus 9.5 okay, so this one it is equation number 1. This one it is equation number 1. So integrate with respect to x. Integrate above equation with respect to x okay, so now ei d2y by dx square it will get dy by dx dy by dx dy by dx dy by dx is equal to, so it will be 12 x integration it will be x square by 2, it will get x square by 2 x square by 2 x square by 2 square by 2 then minus 12 in bracket x minus 3 bracket square x minus 3 bracket square divided by 2 divided by 2 divided by 2 then minus 8 in bracket x minus 9.5 x minus x minus 9.5 x minus 9.5 square x minus 9.5 square divided by 2 divided by 2 then plus c1 okay, c1. So again integrate with respect to x, again integrate with respect to x so ei into y is equal to so again it will be 12 into x cube divided by 3. So x square integration it will be x cube divided by 3. X cube divided by 3 into 2 it will be get 6. X cube divided by 6. Then minus 12 into in bracket x minus 3 cube divided by 3 into 2 it will be again 6 6, 6, 6, -8, -8, x minus 9.5 cube, 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 divided by 6, divided by 6. So constant C1, integration of C1, it will be C1x, then plus C2, C2 plus C2. Okay, so this one it is. So this one equation number 2, and this one it is equation number 3. Okay, equation number 3. Equation number 3. Okay. So now apply boundary condition. Here we need to apply boundary condition. To apply boundary condition, boundary condition, comma, when x is equal to 0, when x is equal to 0, comma, y is equal to 0, put in equation 3. Put in equation 3. Okay, put in equation number 3. So when x is equal to 0, so this term it will be get 0 is equal to, so 12 into, so this term it will be also get 0, so 0, then this term it will be get minus value actually. Okay, 0 minus 3. So here if we got minus value, so we'll take this term, it is also totally 0. Okay, so minus, here it will be also get minus value, -8 into x minus 9.5, x minus 9.5, x it will be 3 minus 9.5, it will be get minus value, so it will be take 0 value, then C1 it will be get 0 value, then plus C2. Okay, so C2 is equal to, it will be get 0, C2 is equal to, it will be get 0. Okay, so apply second boundary condition. Second boundary condition, when second boundary condition, second boundary condition, second boundary condition, when x is equal to, when x is equal to, when x is equal to 14 meter, 14 meter, comma, y is equal to 0, y is equal to 0. Okay, so put in equation 3. Put in equation 3. Put in equation 3. Okay, so again, so EI y0 it will get 0 is equal to 12 into x cube by 6. X it will be 14. 14 cube divided by 6. 14 cube divided by 6. 14 cube divided by 6. 6. Then minus 12 into 14 minus 3, it will be how much? 14 minus 3, it will be 11 cube. Again 11 cube, 11 cube, 11 cube divided by 6. 11 cube divided by 6. 6. Then plus, sorry, minus 8. 8. So 14 minus 9.5. 14 minus 9.5. It will be 4.5. 4.5 cube. 4.5 cube divided by 4.5 cube divided by 6. Divided by 6. 6. Then plus C1x. X it will be 14. X it will be 14. And C2 value it will be 0. C2 value it will be, we are calculated 0. So from this relation it will be get C2 value. Okay, so we need to calculate C2 value. So 0 is equal to 14 raised to 3 divided by 6 into 12. 14 raised to 3 divided by 6 14 raised to 3 divided by 6 into 12. So it will be 5488 minus 11 raised to 3 divided by 6 into 12. So it will be get 2662, then minus 4.5 raised to 3 divided by 6 into 8. It will be 121.5, then plus C1 into 14, C1 into 14, C1 into 14, C1 into 14. So C1 is equal to, it will be get from this relation, 5488 minus 2662, then minus 121.5. Okay. So divided by 14. So it will be C1 is equal to minus 193, 193.178, 178. This one it is C1 value. So put C1 values, put C1 and C2 value in equation 3. Okay. So I will here put C1, C2 value in equation number 3. I will write here. Put C1 and C2 value in equation 3. In equation 3. So EI y is equal to 12 into x cube by 3, 12 into x cube by 6, 12 into x cube by 6, cube by 6, then minus 12 into in bracket x minus 3 bracket cube, x minus 3 bracket cube, minus 3 bracket cube divided by 6, divided by 6, then minus 8 in bracket x minus 9.5 bracket cube divided by 6, divided by 6, divided by 6, divided by 6, then minus C1 it will be 193.178x and C2 it will be 0. Okay, so this one it is deflection equation. You can write down this one, it is equation number 4. Okay, equation number 4. You can say it will be deflection equation also. Okay, so now first we need to calculate deflection at C. Okay, so deflection at C, deflection at C, deflection at C. So put x is equal to 3 meter, x is equal to 3 meter, and y is equal to yc, in equation 4, in equation 4, in equation 4. Okay. Okay, so from A distance A to C it will be 3 meter. That's why you put x is equal to 3 meter in equation number 4. Okay, so it will get EI into YC is equal to is equal to 12 into x cube by 6. X it will be here 3 cube divided by 6, 3 cube divided by 6 divided by 6 divided by 6. Then minus 12 x it will be 3. 3 minus 3 it will be this term 0. Then here we will be, if you put x is equal to 3 meter, 3 minus 9.5, so it will be get this value is it will be minus. Okay, so if it is get negative value, so you can put it is directly 0. Okay, so second term it will be 0, minus third term it will be also 0. Then minus 193.178 into x it will be 3 meter. Okay, so now you can put here yc is equal to, so once again ei yc is equal to, so 3 cap 3 it will be 27 divided by 6 into 12, so it will be 54, then minus 193.178 into 3, it will be 579.534. Okay, so yc is equal to, you can write down now, yc is equal to 54 minus 579.534, it will be minus 525.534, and ei value we know that ei it will be calculated. So this one it is 32 into 10 raised to the power 32 into 10 raised to the power 3. Okay, it will get yc is equal to, from this relation, divided by 32 into 10 raised to the power 3. Okay, it will be get minus 0.0164 in meter, 1642 in meter. Okay, convert it is in mm, yc is equal to, so multiply by 1000. Okay, meter to mm, so minus 16.422, minus 16.422, it is in mm. Okay, so deflection at c we got minus 16.4422. So now calculate deflection at d. So deflection at d, second question, it is deflection at d. Deflection at d. So put x is equal to 9.5 meter, and y is equal to yd in equation 4. Okay, in equation 4. Okay. So ei yd is equal to, so 12 into, so x it will be here 9.5, so 9.5 cube divided by 6, divided by 6, then again minus 12 in bracket 9.5 minus 3, how much, 9.5 minus 3, it will be 6.5. Okay, this one it is 6.5 cube divided by 3, divided by 3, okay, divided by 3, sorry 6 divided by 6. Then next minus 8, 9.5 minus 9.5, those, so this term it will be get 0. Then minus 193.178 into 9.5. Okay, so now ei yd is equal to ei yd is equal to, so 9.5 cube, 9.5 cube divided by 6 into 12. Okay, so it will be at 1714.75, then minus 6.5 cube divided by 6 into 12. So 549.25, then minus 193.178 into 9.5. Okay, so this one it will be 1835.191. Okay, so yd is equal to, you can write down now. First of all, 1714.75 minus 549.25 minus 1835.191. It will be minus 691 divided by 32 into 10 raised to the power 3. 32 into 10 raised to the power 3. Okay, it will get yd. So 669.691 divided by 32 into 10 raised to the power 3. So it will get minus 0.02092 in meter. So convert it is in mm. Means multiply by 1000 meter to mm. So it will be minus 20.927 mm. Okay, so minus indicate deflection, it is in downward direction. That's why we got value in negative value. Okay, so this is deflection at C and deflection at D. We are calculated by Macaulay's method. Okay.